In the early 60s, scientists were asked to develop a life detection apparatus. That is, how can you tell a planet has life on it? In fact, NASA approached the scientific community with this problem.
I was hired by NASA in 1961, it's a long time ago, mainly because I'd invented a number of exceedingly sensitive detection devices.
And I want to tell you how NASA asking the question has changed so dramatically our views of the Earth as a planet. The Gaia hypothesis says that you can detect life from an atmosphere of a planet.
If the atmosphere is completely at equilibrium or near to it, then there's unlikely to be any life on the planet.
The atmosphere. We are bathed in it. It connects each of us to each other. It transports much of the matter that life uses to make itself.
I was sitting in a room, an office that I shared with Carl Sagan at JPL, and we were discussing life on Mars and how to find it, when in marched an astronomer, Lou Kaplan, with his arms full of sheets of paper. And we all said, well, what's this? And when we looked at it closely, it was the complete analysis of the Martian and Venus atmospheres. And we said to Lou, well, interpret it for us. What's it mean? He said it means that the atmospheres of both planets are almost entirely carbon dioxide with only traces of the other gases present. And I immediately knew this meant that they were both dead planets.
The Earth as a planet is profoundly different from our sister planets, that is Mars on the one hand and Venus on the other. And the differences have to be understood as a product of life.
If you look at the Earth's atmosphere, it's wildly out of equilibrium. Incredibly. Just think of it, there's methane and oxygen mixed. If they have different composition, it would blow up. And something must be regulating, or they wouldn't stay constant.
Gas composition of the lower atmosphere, the temperature, the oxidation state, that these aspects of the lower atmosphere are modified by the presence of living organisms in such a way as to regulate the atmosphere to keep these aspects within a range suitable for life on the surface. It says, therefore, that the lower atmosphere is not a passive environment, but it's an actively modulated environment for life on the surface.
And that was my eureka moment. Here was this great system that was looking after itself and keeping the planet habitable.
The conventional wisdom held by geologists was that life was a kind of passenger on the Earth.
The Earth was thought of as basically a dead ball of rock with a thin smear of life on its surface that didn't have any influence or much influence on what the composition of the surface looked like. And the geologists were in charge, and there were different departments, geology, meteorology, chemistry, and they didn't really talk to each other very much. So that's a fragmented, reductionist approach to understanding the Earth.
Now the Gaia notion is quite different. It sees the evolution of life and the evolution of the planet as not two processes, but one single tightly coupled process.
The rocks, the atmosphere, the biota, they're tightly coupled. They interact as a system.
It is hard to believe, from an astronomical point of view, that the temperature is simply by accident maintained constant. We prefer to believe that there's an active temperature regulating system, and when we look around, we see that it is really the sum of the organisms and their activities that have the potential for regulating the temperature.
I'd first come along and published on Gaia in 1965, long before I met Lynn.
He intuited that Gaia existed and that Gaia must work, but he couldn't say how, and I think Lynn played a key role in getting him thinking in a way that together they could begin to say how it could happen.
It was about 1971, I think, when she asked Carl, by then they were divorced, did anybody know about oxygen in the atmosphere and how it came and what role it played. And he sort of hummed and hawed and eventually said, well, you better speak to Jim Lovelock. And he's got some strange ideas on how the atmosphere came about. She was probably more aware than anybody I'd met about the role of bacteria, microorganisms generally, in the infrastructure of the Earth.
We think it's the major groups of bacteria that actually are running the Gaian system.
And this was an incredibly valuable contribution. Most scientists before then, if not all, tended to regard the bacteria as something in a pathology lab. They didn't think the whole show was running on them.
There's something more than chemistry on the surface of the planet, and this more than chemistry turns out to be life, and that is the basic idea.
We got on exceedingly well. It was she was the first person I'd met that would listen to anything I had to say about Gaia.
I love Jim Lovelock. I think he's the most original, mischievous, anti-academic mind I've ever met. He's totally original and very science-grounded.
And that allowed them together, I think, in the early 70s to have this extraordinary outburst of creativity, suggesting all kinds of extraordinary ways in which life could be involved in regulating methane in the atmosphere and in turn oxygen in the atmosphere. How bacterial life was entwined in what we call the biogeochemical cycles that support life. Some of those ideas have stood the test of time and others of course haven't, but it was the creative outburst, if you like, in this interdisciplinary fusion that is incarnated in those two people. You have the depth of insight into biology from Lynn on the one hand, and you have this physical, chemical and almost philosophical reasoning of Jim Lovelock on the other. It basically arose as an idea, Gaia, almost in some ways arguably at the wrong time, because it arose at a time when biologists were trying to purge any notion of things being for the good of the species or for the good of the collective out of their theory.
The criticisms of the neo-Darwinists were getting almost out of hand by then.
What I'm not happy about is to talk about the function of a particular gas in the regulation of the biosphere, because it implies that individual organisms that are manufacturing that gas are doing it for the good of the biosphere. It further implies that if it were bad for them as individuals, they might still do it, because that's the only way the biosphere will persist. And the real danger is that people will assume that individual organisms will sacrifice themselves for the benefit of the entire system. And that's wrong, and it's dangerously wrong in the sense that it's very, very widely believed among laymen and even among professionals.
Neo-Darwinism, which was a sort of developed branch of Darwin's great theory, seemed to be taken by many as the final last word there was on the subject, which is always dangerous. And they wrongly assumed that Gaia was against it.
They sort of saw anything that looked like an argument for cooperation or so forth. And Gaia is like the grandest argument in their eyes of biological cooperation as being somehow heretical to the theory.
I mean, one senior British scientist, John Maynard Smith, referred to Gaia as an evil religion, and they were intemperate in their language generally. And Lynn was very combative and would usually fight them. And what was it Richard Dawkins referred to as Attila the Hen? Yes, that was Lynn. And she was right, of course, and he was wrong.
Since we have not discovered or worked out all the mechanistic details, and I certainly agree we are nowhere near having finished that job. People say, I don't believe it, you don't have a mechanism, therefore the phenomenon of regulation doesn't exist. Those people will be biting their tongues another decade or so.
We found mechanisms. We showed that but for life, the carbon dioxide in the atmosphere now would be so great that we'd be fried. Life has pumped it down continuously so that it's low. There is a mechanism, the pumping out of carbon dioxide to keep the planet cool. Now we've discovered another mechanism. Clouds are produced by the algae over the oceans.
they didn't really ever read any of the papers on Gaia. They just got scuttlebutt from their students. And I've even got this in writing from William Hamilton. He apologised for never having read my papers and just assumed that what was said around about Gaia was correct.
Do you think the name was
Yeah,
a
probably.
problem?
Yeah, but what would you have done? I mean, it so happened I lived in a village with Bill Golding.
So he said in total frustration to Golding, I need a good four-letter word to focus the attention of my colleagues because I'm not getting anywhere. And Golding, who's a very literary person, said Gaia, that means goddess of the earth. And he said, perfect, wonderful, I buy it, and that's how it happened.
However, because of its mythological connotations, that immediately gets up the backs of a number of purist scientists who would rather have less laden language.
Jim Lovelock says, which is wonderful, he said, well, let them think the earth is a pile of rocks and they can kick it, but let them think that it's a live organism, they respect it. And I say, that's not right, Jim.
I look on the earth as a living object. I think the definition of life needs refining.
To me, the Gaia theory is absolutely not the earth is an organism. It's the earth is a physiological system made up of ecosystems, themselves made up of communities, and that the minimal unit is a cell.